Hi there, friends of physics. My name is George, and I will try to explain how quantum entanglement happens and why it happens. I think I found a solution to this paradox. And if you don't know what quantum entanglement is, of course you can search it and you can find very, very good videos for it and understand what happens. This video is not an analysis of what happens. I will just explain why it happens and how it happens. As we know in the quantum entanglement, when we entangle two particles, they can exchange information in a very long distance instantly. That means faster than the speed of light. And not only they can exchange information faster than the speed of light, but also according to the delayed choice experiment, this information, if we take a measurement in one of those two particles, this information goes to the other particle at the past of this particle. That means that we start entangle two particles, let's say at 10 o'clock, and then we measure one of them at 11 o'clock, and the information is already at the other particle at 10 o'clock, which is of course paradoxical, and we can, at least I haven't heard an explanation for why this happens. This is what I will try to do today. I had this thought in my mind the other day, thinking about this problem, and I think that I have found a solution for it. So this is the solution. According to Einstein's theory of relativity, as you approach the speed of light, if you can observe the rest of the universe, you observe that time starts run faster. If, for instance, you have a clock somewhere in the world and you start running and you're approaching the speed of light and you can observe this clock, you will see the clock run faster and faster. The closer you get to the speed of light, the faster this clock runs. That is proven in physics, of course, and I will base my theory on this proof. That simple means if we can imagine that we run close to the speed of light and the time outside of us runs, let's say, twice as fast as our time, that means that if we travel for 1 minute for our time and we can observe this clock outside of us, 2 minutes will pass in the external environment. If you can imagine that you observe this clock in various moments throughout that minute that you travel, you will see that every time you watch this clock, the time has passed twice as your time, meaning that if you observe this clock at 10 seconds, you will see it, say, 20 seconds, and if you observe it 30 seconds, the clock will say 1 minute, and when you go to 1 minute, the clock will say 2 minutes. Now, if we can draw this, it will look something like, I will try to draw it here in a small image for you, so you can see it and understand what I will say later. If we can see this drawing, we see that everything that happens in that period of time for the external world, in these 2 minutes, we experience all those moments of time in 1 minute. And if we take that in mind and we actually try and run even faster, we will see that at some point, the more we approach the speed of light, the external time will be 4 times as fast, or 10 times as fast, or 100 times as fast. That means that 100 minutes of outside time, we will experience those 100 minutes in 1 minute, if the time is 100 times faster, of course. that means that all those facts that will take place and happen in this 100 minute period, we will see them happen in 1 minute. Now, if we take this further and for one moment we try to think what happens when we actually reach the speed of light. Well, according to Einstein, when we reach the speed of light, the external time actually is infinite times faster than our time. That means practically that when we reach the speed of light, that happens at one moment. It's not a long period of time. The one moment we don't run with the speed of light, and the next moment we run with the speed of light. That means that at that exact moment that we have reached the speed of light, we experience all facts and everything that will happen in time from that moment and on to the infinity. We experience all those things at the same time. So all things happen for us that we reach the speed of light at exactly the moment that we have reached this speed. And we see all time at the same time, sort of. Now, if we take this thought and we take it back to the quantum entanglement experiment, and we can imagine two particles that we have entangled, practically that means that when those particles that also run with the speed of light are entangled at this moment, they are at the same, let's say, space and time, and they exchange some information. But from that moment and on, everything those particles experience for the rest of the world and for the rest of eternity and for the rest of time actually happens for them at the same time. Therefore, if we go and take a measurement at one of these particles after 1 hour or after 2 hours or exactly at the moment that they are entangled, for those particles that is the same thing. It makes no difference, because for a particle that runs with the speed of light, that particle experiences the rest of the universe happen at one single moment. Everything happens at one moment. That means that it makes no difference if we take a measurement of this particle a minute or 2 centuries later. All this time that we experience happens for the particle at the same time. Therefore, when we entangle two particles, each one of those particles experience the rest of the universe and all time happen instantly. So when you entangle these two particles and you bring them together at a specific space and at specific time, that means that for then and on to the infinity, all kinds of let's say experiences that those particles will have with the rest of the universe will happen at this point of time and at this space, because those particles, both of them, experience all universe at the same, like everything happens at the same time. So when you do something to one of them after a specific period of time, it's like doing it to it for all its existence. Therefore, when you entangle two particles, everything that you do to one of them, this thing is like you do it also at the moment that those two particles came together. So it's perfectly logical, if you think it that way, that this information has also gone to the other particle, because it's like what you do to one of those particles, you do it at exactly this moment, the moment that they were entangled. So that, for me at least, explains this problem. If you think it that way, if you can imagine that you are a particle and you run with the speed of light, and you can imagine that you experience everything that happens to you at the same moment, no matter when it happens and no matter where it happens. This also happens for space. When you run with the speed of light and you go through space, at every given moment you are at a point of space, but you experience all those moments happen at the same time for you. That means that also space is at the same point that you are. It's like all things come to you and you don't actually run through space, because at the same time you experience all those different places of space and all those different times. And that also, of course, explains the delayed choice experiment, because when you take two particles, two photons, and you entangle them and you run them through this delayed choice experiment, also the delayed choice eraser experiment, it's the same thing. If you take those two photons and you entangle them together, from there, that moment and after, whatever you do to them, it's like you do it at exactly this moment, the moment that you have entangled them together. So this is how it looks for us, of course, like those particles exchange information from far away or at another time, and they can exchange this information independent of time. But this really doesn't happen for the particles. The particles experience all this time at the same time. This is the best way I can explain this in English, because it is not my native language, and I'm really trying here to explain it as clear and the best way I can. So I hope you understand what I'm trying to say, and please feel free to send this video to physicists and mathematicians, so they can actually write down a more official and mathematical solution for this. Even though I don't think that this is something that needs a mathematical solution, because if you think it logically, for me now, this delayed choice experiment is not a paradox. For me now it's totally logical, because I think now I have this solution in my mind, and I can understand that for the particles, all things that happen in time happen actually at one single moment. So it's perfectly logical what happens in this experiment, and I hope that this is the solution for this experiment. Thank you very much for watching, for being patient with me, with my poor English, and feel free to share this video with other people, so that physicists and mathematicians will actually look this video, and maybe they can actually understand more about this phenomenon. Thank you very much.